Hello everyone. Tonight's lecture involves learning how to calculate the molecular formula of a given compound. We've talked before that ionic compounds are written in their empirical formula, but covalent compounds tend to be written in their molecular formulas so that we can distinguish between them. So tonight we're going to see how that actually happens mathematically. Please take a moment and copy down the rules, and I will show you how to implement these steps in the following problems. Before we start, I would like you to pause and copy down the example problem. You need to have the problem in your notes in order to be able to reflect back on it and know what the question was asking. All right, let's take a look at this problem. In this problem, we are given an empirical formula of CH2O. And we're told that the molar mass of the molecular formula is 90 grams per mole. So half the battle is there. If you look at your rules, the first step is that if you don't have if you don't have the empirical formula, you need to calculate it. Well, we're given the empirical formula, so that's all it's taken care of for us. The next step then is for us to get the molar mass of the empirical formula. So we have one carbon at 12.01 grams per mole. We have two hydrogens, that's 2.02 grams per mole, and one oxygen is 16 grams per mole. When we add that all up, we get 30.03 grams per mole for our molar mass of our empirical formula. Now, the next step tells us to determine the molecular factor. So we need to take the given molar mass of the molecular formula, 90 grams per mole, and we're going to divide it by the empirical formula's molar mass of 30.03 grams per mole. When we do this, we get an answer of 3. The units cancel. The last step that we do is we apply this factor to the empirical formula. So we're going to take 3 times CH2O, and we're going to multiply the subscripts by this factor. So our molecular formula becomes C3H6O3. In this last example, I'd like you to take a minute and copy down the problem. In this problem, we are not given the empirical formula, so we have to calculate that first. Let's refresh our memories from the other night. If we're given percentages, which we are in this example problem, we assume a 100-gram sample, we drop the percent sign, and add a G for grams. So we're going to start with 92.2 grams of carbon and 7.8 grams of hydrogen. We then convert the mass to moles using the molar mass of each element. And when we do this, we get 7.68 moles of carbon. And again, we don't use Brinkelhoff for empirical formula because the element is in a bond. We have to remember that. So we just use the 1.01 for hydrogen, and we get 7.72 moles of hydrogen. We then divide by the lowest mole value, 7.68. And for all intents and purposes, we get 1 for both. So that means that our empirical formula, let's move this over here. Our empirical formula is CH. Now we can go on and calculate the molecular formula. So here's our empirical formula. Let's apply that to calculate the molecular formula. We first have to get the factor by which we're going to multiply the subscripts of the empirical formula. In order to do this, we need to use the molar mass that's given to us in the problem of the molecular formula. So we take 78 grams per mole, and we need to divide this by the molar mass of the empirical formula. Well, when you take 12.01 plus 1.01, we get 13.02 grams per mole for our empirical formula. When you do this division, you get a factor of 6. So we're going to multiply that by our empirical formula. When we do this, we get a molecular formula of C6H6. So this is our molecular formula. This is how you complete a problem in which you have to first calculate the empirical formula from the data given, and then calculate the molecular formula from that. It's a little bit longer, but it's not any more complicated in terms of math. Tomorrow we're going to do some practice problems. Have a great evening.